It's time for the conclusions and practice. Okay, so we're going to start with question 1. Question 1 is sort of worded funny. I'm sorry about that. So hang in there, and maybe hearing it will be better than just kind of reading it. So the question is, does how we describe the motion of objects depend on which object is the one describing the motion? So give an example to support it. So when you're thinking back to your lab, if you were looking at one object moving, was it the same from both the tree and the scooter, or from the scooter itself and the tree? So think about that for a second, and I'm going to have a pensive thought face. You can pause it, write your answer down, and come back. You done? Okay, so now we need to look at our answer for this. So does how we describe the motion of objects depend on which object is the one describing the motion? Yes, it totally is dependent upon what the object is. You could have had lots of examples here from the tree looked stationary, to the scooter, to the tree looked like it was moving based on the scooter. Like moving from the scooter. Okay, that's one example. There were a lot of different things you could have put down for here. Okay, so now we move on. I'm going to have you do questions 2 and 3, make a guess, and then we'll pause it, and you can come back afterwards. Actually, you know what? How about this? I'm just going to read it. You can pause it, and then I'm not going to give you an answer for that one. You could just move on to number 4. We'll talk more about numbers 2 and 3 tomorrow in class. Okay? So what do you think the term relative motion means after doing this lab? And what do you think a reference point is after doing this lab? So first thing you want to probably know, in this case, relative motion doesn't mean like uncle, cousin, sister, aunt, whatever. It means compared. So that's a hint about relative, means compared. And then think about reference point. Okay? Here's another thoughtful face. Did you pause it? I'll do it again. Okay. So now we're ready to move on to number 4. So number 4 is a little tricky. You are going, oh good, you can see it. You're going to look at this picture here, and I've got color, it's kind of fun, and I've given you some options. So what you're going to do is you're going to look at the car and the 2 buses, and we're looking at these blue arrows, and yours aren't blue, yours are just striped, and we're going to use that information to fill in a different kind of motion perception, I guess. So let's start off with these blue and blue arrows here. Which one do you think is going the fastest? Think about it for a second. Okay, so you should have chosen the car is the fastest, and why? Well, the arrow is the longest, and in vectors, a longer arrow, bigger arrow means that there's more speed or more force, and in this case, it's more speed. So this car is going the fastest. Well, now what we're going to do is, using that information, which tells us both the direction and the speed, we're going to fill in the rest of these boxes with these other terms or arrows when you are pretending that you're driving in the car. So take a minute. I want you to sit in the car in your mind. Go ahead, it's okay. And you're going to imagine sitting there and look down at the ground. Do you feel like one of these arrows here is going to represent, or this no motion, what your body looks like sitting in the car? So take a pause and come back. Pause. Okay, what did you think? Okay, so let's look. If we're sitting in the car, just right now, do it in your chair. Look down at the ground, and you look at yourself sitting in your chair. Are you moving? No. Well, the same thing's going to happen with this car, so this would be no motion. Okay, well, now let's look at bus number 2. And guess what? This is just like scene number 4, where we had one of the scooters going faster than the other. So if this car is going faster than this bus, take a minute, talk about what you think would happen if we have this situation set up and you're in the car. How would the motion of bus 2 compare to the car? So I'll give you another face. Okay, so what do you think? So we've got this bus moving slower than this. Therefore, we think it should be moving backwards, which is that funny situation we just talked about. All right, so we've got this one seeming like it's going backwards. Well, this bus is going from the other side of the road, and it's coming toward the car. But it already has its own speed, and so does the car. So take a minute. Here's another face. You're back? Did you pause it? Good. All right, so what do you think is going to happen? Well, this bus is already zooming past, and the car is zooming past, so it's going to appear that it's going in the same direction, but the arrow should be longer because it seems like it's going fast. Just imagine like you're on the freeway and you see the cars and they go back pretty quickly. Well, that's kind of the what's going to happen in this situation. All right, so we've got some good practice. I know I'm going to totally regret doing those stupid pause faces, but whatever, for the name of you guys being able to laugh at your teacher a little bit. And so what we're going to do then is reconvene, talk more about how to describe motion with some notes and some more practice, just like kind of similar to what we did with the bus thing. All right, good job.